A very good morning and welcome back to my channel, which is DJ Cool. So here we are again with a new topic, which is basically dual nature of light. And this is a very easy, very interesting and a very small but very important topic, which describes photon having dual nature. See, we have talked about it a lot of times that light possesses both behaviors. What are those two behaviors? We say that light also acts as a particle and light also acts as a wave. Now, we have certain experiments, or you can say we have certain proofs or evidences which prove that nature of light is particle nature, whereas there are certain phenomena, there are certain processes or observations which shows that light has wave nature. So in a way we say that light photon is a particle and it is a wave at the same time simultaneously. Here we'll be talking about certain terms or certain, you can say, observations or certain phenomena or certain experiments which will prove both the things. So without wasting any time, let's start. Now here, the first thing is collision of electrons. We all know what are electrons. These are elementary particles. We have already talked about how electrons are formed and what are further particles. ब्रेक डाउन अगर हम इलेक्ट्रॉन का करते हैं तो व्हाट आर द फर्दर पार्टिकल्स व्हिच कॉन्स्टिट्यूट इलेक्ट्रॉन्स. So first thing is we know that electrons exist in the shells of an electron. So I've drawn an atom here. Now these are the shells and this is the nucleus, and the electron is revolving around this nucleus into its shells, which are specified shells. Now when we talk about the shells, we talk about energy levels, right? So these are the energy levels. Now what happens is, whenever I am talking about an electron, I am specifying it is present in a certain shell, it is having certain rotation numbers or quantum numbers. So in a way I am, assigning a certain amount of energy to this electron which I am talking about. So how do I assign this energy is, when I'm saying these are shells or subshells, I'm talking about energy levels. Every shell, K, L, M, N, when we do the electronic configurations, every shell has a certain amount of energy which every electron present in that corresponding shell will possess. So when I'm saying this electron is present in this shell will have certain fixed amount of energy, and the another shell or the next shell will have another amount of energy, and in a way we form certain energy levels where n is equals to 1, 2, 3. Now here it is the nucleus. Nucleus is below the first energy level or the ground state energy level, and as we move further, this energy gets converted or it increases. Now all these energies are negative, negative, negative. That means this much amount of energy is to be supplied by any way to the electron present in these shells to observe something, or if it emits, which we'll be talking about. So we say, how does these collisions or these observations come into picture is, I have an electron which is present in a certain shell, and this electron is, you can say, is present in path of certain photon, which is my particle here. It is a particle right now. So I'll say this photon particle is traveling somewhere and this electron comes into its way and these two collide. Now, when we say there is a collision, just like in, you can say, normal life physics, when we talk about collisions, there is a transfer of momentum, there is a transfer of energy. So here what will happen is, after this collision, I'm saying photon is a packet of energy. It is a packet of energy which will get absorbed by this electron. Now, this electron was present in a certain shell and it got a packet of energy which increased its own energy. Now, what will this electron do? This will depend how much energy was present in that packet. Now, I am saying there are certain energy levels E1, E2, E3, E4, E5. One thing is for sure that this electron can only be present into these electron or energy levels. So either it is in this level or in this level or in this or this or this. It will never be present कहीं पर भी इन levels के बीच में. It will always be present into certain energy level, and hence this packet of energy should be in such a way that when this packet of energy is absorbed by this electron, it should be sufficient to make the electron jump from this energy level to the next one. If it is less than that energy, electron will only absorb this energy and it will do nothing, right? So we say if the incident energy is sufficient, the electron can jump to the higher energy state after it absorbs the energy of this packet of photon. But this is only possible if the energy of the incident photon is equal to the energy difference of two energy levels. I am not saying that this energy difference is equal to something constant. Why? Because the energy difference between these energy levels is different for all levels. Also, suppose my energy is so high that my electron can jump from this energy to this energy and again to this energy. This can also happen. But this energy should be in a way that it helps this electron to jump over. It should be sufficient for that jump. But if this energy is not sufficient or it is maybe 0.1% less than the required one, nothing will happen. Nothing will be observed, no change occurs, and basically nothing happens. So this is collision of electrons. Are we clear? Energy levels, are we clear? Let's move forward. Now the next thing is this electron. Now this particular electron is the hero or the lead role of this movie. So whatever happens, it will happen around this electron only. So this electron, as we say in the movie, that just before the lead role or the lead character is instigated, he is always living a normal life, a very common man life, until and unless he or she is instigated. So same way, until and unless we are instigating this electron, it will do nothing. Now, how do we instigate this electron, or how do we excite this electron? We basically have three ways. First, which we discussed right now, if it absorbs a photon energy. Second is thermal or heat energy, which is maybe due to friction or maybe due to agitation or direct heating, which we mainly talk about in solid states, that are due to rise in temperature of the surrounding, that electrons get excited by absorbing the thermal energy and it leaves its place or it comes into the interstitial voids. So this is in general that electron can also absorb the thermal or heat energy. Third is electron. It is a charge. It is a charge which is moving, so it is a current, and when there is a wire and some current is flowing through that wire, so its electron gets excited and it starts showing certain movements. So basically we have three ways to excite this electron, and which is the most important is this one, because we are concerned only about the photon energy, since we are talking about the dual nature of light, or we can say wave nature or particle nature. Now there are certain amount of energies which are required to obtain certain reactions or obtain certain changes in a molecule or an atom, and we have assigned certain names to these energies. Now The names are very easy. It actually tells me what in which type of energy it is. So first is excitation energy. We are talking about an electron which we need to excite. So excite say he excitation energy, right? Now excitation means that it will be the amount of energy which will be related only to excite the electron, and nothing happens. We are just exciting it. We are just telling him, don't sit, just stand at your own place, right? So this is the amount of energy absorbed by the electron in any way. Here we will be talking about the photon energy to jump between the energy levels. That means this is my atom, this is the amount of energy which will be absorbed by this electron so that he can jump in between these energy levels, but it can not escape this atom. Atom ke andar he can shift from one energy level to another energy level. Second is ionization energy. Now, before I go to ionization energy, what is an ion? So I say there is an atom which is electrically neutral, but if due to anything it loses or gains an electron, it gets charged positive or negative depending upon the you can say interchange of electrons. We call that atom as an ion. So it means certain amount of electrons are either released or absorbed. That means atom से अंदर बाहर electron हो रहा है. So I'll say it is the amount of energy absorbed by the electron which is sufficient for the electron to escape the atom. Right? Escape the atom. So I am talking only about releasing the electron. I'm not talking about absorbing it. It is the release of electron. So I'll say it is the amount of energy which is sufficient for the electron to escape the atom. Now, I know two kinds of energy now, which is the excitation energy, which is the amount of energy absorbed by the electron so that he can jump in between the energy levels without escaping. But ionization energy is little bit higher to the excitation energy because ionization energy is sufficient for the electron to escape the atom. Now, I am saying that certain amount of electrons are either released or absorbed during some interaction or some energy exchanges. What are the observations now? Now, electrons are elementary particles. We cannot observe them with naked eyes, or these reactions we cannot observe them. So we say that I have, since we are talking about the absorption of photon energy, I have a spectrum. Now, what is a spectrum? Spectrum is basically a range of frequencies or a range of wavelengths which are either present or are to be created, right? First we'll be talking about the absorption spectra. So in this case I'll say I have a certain range of frequencies into this room. Now, since I'm saying that I have this range of frequency which is a continuous frequency range, so I mean that every possible frequency which lies in this range will be present in this room. Now, suppose this is certain material and this certain material has electrons which are going to absorb the frequencies or the light or the photon energy of all the frequencies present in this room, and either it will absorb the excitation energy and move into its energy levels, or these electrons will absorb the ionization energy and this material will get converted to an ion. So I say absorption spectra is observed where the electron has observed, not observed, it is absorbed energy of the incident photon of a certain frequency required to jump between the levels, right? I have a range of frequency present here. Electron which is present in the sample material will absorbed a certain frequencies key photon, and it will jump in between its energy levels. These absorbed frequencies are missing from the continuous spectra. Now, you can understand it in a way that I have 10 balls which are numbered from 1 to 10, and they have been kept in a series 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I call a child and I say, just pick any 2 or 3 or 4 balls of your choice. Now, I don't know which balls he or she will pick. This kid will come into the room and he will randomly pick certain balls. Now, after he has taken those balls and he has left, I have certain voids. So these certain voids will be empty spaces. So in the similar way, when I was saying that I have a certain range of frequencies, out of those frequencies, a certain number of frequencies have been absorbed by the sample. Now, in place of these frequencies, there will be voids or empty spaces. And when I say there are certain frequencies, that means there are light of every color present here. And when I say certain frequencies are absorbed, that means darkness has left there. So I'll say these are the colors which are present in the room, and my sample has absorbed certain frequencies, after which certain voids are left. So this frequency is absorbed, this one, this one, this one, this one. So this is the kind of absorption spectra which we finally receive after studying certain, you can say, reactions or absorption of photon energy, right? So this is my absorption spectrum. Now, the formula for this absorption spectrum is E1 minus E2 is equals to HF. We all know that energy of a wave is given by E is equals to HF, right? So when I'm saying HF, H is a constant, so F, which frequency will be absorbed? So I say, since here the energy is being absorbed, that means my electron will rise to a higher level. So this delta E will be E1 minus E2 will be equals to H. So if I need to find the frequency, it will be E1 minus E2 divided by H, and I'll get the frequency which will be absorbed. Now, second is emission spectra. Now, we have certain, you can say, chemicals these days, like which are glow in the dark. We have printed t-shirts or certain bangles which glow in the dark. So what are those? Those are certain chemicals or which have been formed by adding or making a mixture of certain elements, or you can say metals and non-metals. So what these objects do is, this room is totally dark. I have that sample in my hand, and this sample will release certain frequencies. Now, this room is completely dark, and now my sample will release certain frequencies. So again, very simple. I have a complete dark room which is empty, but my sample is releasing out certain frequencies, and whenever these frequencies are released, there will be illumination, right? So this is my emission spectrum. It is observed when an electron is de-excited. Now, de-excited means I have a certain electron which was present in this energy level. It absorbed certain photon energy from any photon, and it rose to the next level. Now, reaching this level, it got very unstable, and to get stabilized, this electron needs to emit out the energy. So what it does is, it releases energy again in form of a photon. So I say this becomes unstable, 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 unstable. So it releases energy in form of photon, which is HF again. So this amount of energy this electron will emit, which will be observed as sparks. So I say it is observed when an electron is de-excited, thus coming down, and loses energy by emitting photon of certain frequencies. It is always observed as colored lines of emitted frequency. जितनी भी frequencies release की जाएगी या emit की जाएगी, those will be the colorful sparks. Now again, in this case, since it is coming from E2 to E1, this will be E2 minus E1 will be HF. So F, if I know, I can know the energy levels. If I know which is the initial energy level and I know the amount frequency which is being emitted or absorbed, I can tell the final energy level where the electron will land. But if you observe in both the cases, this is delta E, this is delta N, it is equal to HF, which is, if I say that I have a certain range of wavelengths, so my formula will become delta E is equals to Hc by lambda. Clear hai? Any doubt till here? You can leave in the comment section. I'll reply as soon as possible. Next is electron volt. Now, when we talk about energy, we always say energy is counted in terms of joules, calories, but we have another unit for energy, which is electron volt. Now, whenever we are talking about an electron which is in motion under certain forces or under certain potential differences, we count that energy in terms of electron volts. Why? Because it makes it very much easier. So how do we define electron volt? We say the kinetic energy of a charge Q which is moving through a potential difference of V will be given as kinetic energy is equals to Q into V, which is charge into potential difference. But when I say the elementary charge, that means electron is 1.6 into 10 to power minus 19 coulombs. And when this electron moves through a potential difference of 1 volt, I'll say the kinetic energy of this electron will be 1 electron volt, which is in itself its definition. So the definition of 1 electron volt is the amount of energy, amount of kinetic energy of an electron which is moving under a potential difference of 1 volt, and this is a new unit of kinetic energy. So now we know what is excitation energy, we know what is ionization energy. So what is threshold frequency now? I said that whenever we'll be talking about energy, in case of waves, I'll say energy will be given by HF, right? Where H is a constant, so that means energy is directly dependent on frequency. Now, we are always talking about the minimum amount of energy to excite an electron, minimum amount of energy to make the electron escape the atom. So, this minimum word, minimum amount of this energy for any process to happen, for any process in this world to happen, there is a certain minimum energy required of the corresponding form, and this minimum amount is always known as the threshold frequency, threshold energy, threshold wavelength, threshold speed. Like you can say the escape velocity, which we talk about the rockets whenever we are launching a rocket. Those rockets are provided with certain escape velocity. It is again the minimum amount of velocity which this rocket should have at the time of launching so that it escapes the gravitational field of the earth. So this minimum word, whenever it comes with certain quantity, that quantity becomes a threshold quantity. When we are talking about the threshold frequency, it will be the minimum amount of or the minimum frequency which will cause an electron to be released or to be ejected from where? From the surface of a metal. And since the minimum energy, minimum word is present here, which is causing an electron to be released, it will be given as E minimum will be given as HF minimum. This will be my threshold energy, threshold frequency corresponding to threshold energy. Now, as I said, threshold speed or threshold velocity while we are talking about the rocket is known as the escape velocity. Here we are directly using the threshold word, but the next, which is the key topic of this lecture, which is the photoelectric effect. In case of photoelectric effect, this threshold word will be replaced with work function, denoted by phi. So what is work function? First thing is it is intrinsic. That means every metal will have its own fixed constant threshold energy or the work function. So it will define as the minimum energy needed for an electron to escape from the surface of a metal. Again the same thing. It is the minimum amount of energy which is required to cause the ejection of an electron. One electron. I'm not saying a number of electrons. It is since it is a minimum energy, that means the one electron which will be ejected, that amount of energy is my work function. Now work function, since it is constant for every element or sample, so I'll say phi naught will be equals to E naught, and again it will be in terms of frequency, so it will be F naught. This will be the threshold energy. Work function, threshold energy, threshold frequency. One and the same thing, just the names are different. Now, see, I say this is the surface of a metal and there are certain photons which are incident on the surface. Now, what will happen is electrons which are present on the surface of this metal will start absorbing photon energy. Now, if this photon energy is equal to the work function, no electron will be ejected, right? So I say, because even if the electron is ejected, that electron will not have any kinetic energy. The whole amount of energy which is being absorbed by the electron has been used in overcoming all the forces of this sample to keep that electron in itself. But if I say that if the energy of these incident photons is more than the work function, that rest of the energy will get converted to the kinetic energy of the ejected electrons. So in that case, kinetic energy of those ejected electrons will be incident or the absorbed energy minus the work function. The such emitted electrons are known as photoelectrons. Why? Because photons are getting absorbed to eject those electrons. So the source is photons. So we say such emitted electrons are known as the photoelectrons. Emission of these photoelectrons are independent of the intensity of incident. Now this is very important. Suppose I have this surface of metal and I have intensity, if I define it, is the number of photons striking the surface per second per unit area. So it is the number of photons. So I say I have 100 intensity photons which are being incident on this metal surface, but its energy is less than the work function. Will there be any emission of electrons? No, because 100 electrons collectively are not able to supply the minimum threshold work function of this sample. But if I have intensity of 10, which is 10 photons striking this metal surface per unit area per second, but their energy is more than the work function, then there will be emission of electrons. So I say the emission of electrons completely or only depends upon the frequency of the incident photons. This is very important because it always confuses कि इतने intensity से आ रहे हैं, intensity is increased, still there is no emission. Make sure every reasoning question you attempt, make sure and remember that emission of electron only depends upon the frequency or the wavelength. It's one and the same thing. Now, what is stopping potential? आई नो द मिनिमम फ्रीक्वेंसी जो मेरे इलेक्ट्रॉन्स को एमिट करा देगी, आई नो द मिनिमम अमाउंट ऑफ एनर्जी जो मेरे इलेक्ट्रॉन्स को एमिट करा देगी, आई नो द वर्क फंक्शन जिसको मुझे ओवरकम करना पड़ेगा एमिशन ऑफ इलेक्ट्रॉन्स के लिए. बट what is stopping potential? Again, the name itself is telling it. I'm talking about electron volts. That means we are talking about kinetic energy in terms of potential differences. So I say it is the minimum, sorry, not minimal, it is the minimum potential difference required to stop ejection of photoelectrons from the surface of material. Obviously, this is the minimum amount of energy जो emit कराएगी and it is the minimum amount of potential difference जो emission को रोक देगा. So it will be just the opposite of kinetic energy of photoelectrons. कि आपका वर्क फंक्शन के बाद जो काइनेटिक एनर्जी यहां पर कन्वर्ट हो रहा है, दिस काइनेटिक एनर्जी के अगर ऑपोजिट में पोटेंशियल डिफरेंस लगा देती हूं, सो देयर विल बी नो एमिशन ऑफ photoelectrons. So basically, whenever I am asked there are certain frequency photons are incident on a metal surface, this is the strength of the work function and this will be the kinetic energy of the photoelectrons. Find the stopping potential. So what you will do is the kinetic energy of the photoelectrons which are being emitted will be given in terms of calories or joules. All you need to do is just convert that kinetic energy of the photoelectrons into electron volts because it is the stopping potential. I need in terms of potential. That's it. You just have to convert the units. And last but not the least, हमारा main topic which is the photoelectric effect, which I hope अभी तक आपको समझ आ गया होगा because it's very obvious till now कि we are talking about the making photons of certain frequency incident on a metal surface and then the photoelectrons will be emitted out, and this complete scenario or this complete process is known as my photoelectric effect. Photon creating electrons effect. Photons of certain frequency incident on a metal surface, emission of electrons known as the photoelectrons. When a photon of certain frequency is absorbed and its energy causes ejection of electron from the surface of metal, it is known as my photoelectric effect. That's it. It's completely over. This line itself is complete description of this effect or this topic. The electrons thus ejected again are known as the photoelectrons. Also, ejection of these electrons completely depend on the frequency of the incident photons irrespective of their intensity. Now, total energy of the incident photon will be equal to overcoming the work function and the rest of the energy will get converted to kinetic energy of the emitted photoelectrons. Now, if question comes, this is the incident frequency of the incident photons. From this, you know the quantity E, which is HF. Work function of the material is also given. So, you have phi naught and you have been asked find the maximum kinetic energy of the emitted photons. So just you have to rearrange, half mv square stays here only, phi naught comes to the other side and from here you can find the kinetic energy. Also, if someone asks tell me the maximum velocity of these emitted electrons, you know the mass of electron, half is a constant, it goes and gets multiplied. That's it. Also, this phi naught or the work function can be given in two ways. One is it is directly given in terms of volts, electron volts, or it is given in terms of frequency. If it is given in this way, you need this energy also in terms of electron volts. If it is given in this way, so just do the one thing. This is HF and this is HF naught and you get the direct formula. This is all about the photoelectric effect, stopping potential and work function, threshold energy, threshold frequency, electron volt की definition, ionization energy, excitation energy, collision of electrons, how these collisions occur, how the energy is absorbed, what are energy levels, उसके अलावा क्या था? बस यही था. This is all about this topic. This is all about this lecture. If you have any doubt, leave in the comment section. I will get back to you as soon as possible. And do let me know what are your reviews. How do you like these videos? Till then, let's work together. You carry on with your studies. I carry on with your studies. And hopefully, we'll bring the next lecture very soon. Till then, stay tuned. Don't forget to like, share, subscribe to my channel, which is Teacher Cool. Thank you so much.